So for question 11, one of two things might be happening. You might be watching this when I first made this video where there's a typo. So this should have been gamma of t equals t minus 1 gamma t minus 1. If you're taking this at a later time, I was definitely too lazy to create a new video, but I probably was not too lazy to create gamma t here. Just putting that out there, although there was also a good chance that I was just too lazy to do this as well. All right, so we have this gamma t equals t minus 1 gamma t minus 1. So it seems like we might have a lot of integral parts to do here, but it's really not as bad as it might seem. So first off, if I wanted to show this, I'm showing that x, 0 to infinity, x to the t minus 1 is equal, or e to the negative x dx, is equal to t minus 1. And remember, t is a constant, right? So this thing is just a number. Integral 0 to infinity x to the, well, if this is t minus 1, this is going to be t minus 1 minus 1 e to the negative x dx. All right, so we're basically saying that this is t minus 1, 0 to infinity, x to the t minus 2, e to the negative x. All right, so that's what we're trying to show. So let's first start off with just this gamma of t. All right, so if I have gamma t, let's do one integration by parts thing and see what we get. So if I'm going to actually do not column integration here. So if I say u is equal to x to the t minus 1, dv is equal to e to the negative x dx, then my derivative, well, du is t minus 1. We've seen that before. X to the t minus 2. We've seen that before. V is going to be negative e to the negative x dx. So now, when we do our integration by parts, we're going to get this integral is equal to u times v. So that's going to be these things multiplied together. So I have a negative x to the t minus 1, e to the negative x evaluated from 0 to r, right? This is going to be a limit from our improper integral. Sorry, I was a little lazy writing that. Limit as r approaches infinity of this right here. Minus v du, right? So that's going to be these two things together. So that's going to be the antiderivative of, well, I have a negative, so this is going to be plus t minus 1 x to the t minus 2 e to the negative x dx. And at this point, whoa, look at what we got here, right? We got this side, which is exactly the same as this side here. Or we do have these limits of integration, so infinity and 0. And so all we need to do at this point is, can we show that this is 0? Because if we can, well, then I have my gamma t equals 0 plus the thing that we want. So let's go for it. So if I take this limit one more time, I'm going to get the limit as r approaches infinity of, again, I have x to the negative r. So this is like having negative x to the t minus 1 over e to the r minus negative x to the t minus 1 over e to the 0. So, yeah, I'm right. So, my bad. Those aren't x's. This would be an r. R to the t minus 1, r to the t minus 1, 0 to the t minus 1. So, this limit again, no matter how big that polynomial is, the exponential always wins. So this term goes off towards 0. So now I just have minus, well, I have 0 to the t minus 1, which is 0, 0 over 1. So this thing is 0. So we've shown that this term is nothing. So we have gamma t equals this thing, which is t minus 1, which we could pull out because, again, it's not a variable. 0 to infinity, x to the t minus 2, e to the negative x dx. But this thing here is just gamma of t minus 1. So t minus 1 times gamma, or the gamma t minus 1, gives us the result that we were looking for.